Good day, greatens. So in this video, we are going to look at analytical geometry. There is a question here. We are given a quadrilateral, which is EGHF. So this is the quadrilateral that we are given with all these coordinates. This is E. The x coordinate is 14 and the y coordinate is -10. Then we have G with unknown x coordinate and unknown y coordinate. We have H with the x coordinate of -4 and the y coordinate of -6. Then we have F with the x coordinate of 4 and the y coordinate of 6. So this is a quadrilateral, can be a parallelogram, but these are the questions that we are going to look at. There are 6 questions that we are going to do based on this diagram. So the questions they are saying, number 1, calculate the distance HF. Then number 2, they said calculate M, which is the midpoint of EH. This is the M midpoint of EH. Then number 3, they said let's calculate the coordinates of G, this x and y, which is unknown. Then number 4, they said let's calculate the gradient of HF and EF. Then number 5, they said let's calculate the equation of HF and the equation of EF. Then number 6, let's prove if SG is perpendicular to EH. So there are 6 questions. All these questions are based on these 3 concepts of the analytical geometry for grade 10s: the midpoint, the distance, and the gradient. Remember, for grade 10, when you are doing analytical geometry, there are only 3 things that you must be able to do: to find the distance, to find the midpoint, and to find the gradient. Also the equations. So this topic is going to prepare you now for the next topic, which is the functions. So now let's first do number 1, calculate the distance HF. Now this is the coordinate of H, -4 and -6, and these are the coordinates of F, which is 4 and 6. So let's first do this calculation. Now for the distance, now we know the formula that we are using. So this is the formula that we are going to use. The distance between point AF and H is the square root of x of H minus x of F minus x of H squared plus y of F minus y of H squared. So let's substitute now. We are looking for the x coordinate of F. This is the x coordinate of F, which is 4, minus the x coordinate of H. This is the x coordinate of H, which is -4. Then we square it. Then we said plus the y coordinate of F, which is this one, that is 6, minus the y coordinate of H, which is -6. Then we square it. Then we put everything under the square root. So let's do the calculations. We have a positive, negative times a negative, that's a positive. So this is 4 plus 4, which is 4 plus 4 squared, plus we go to this side, negative times negative, then that's going to become 6 plus 6. Then we square it. Then we have to add now 4 plus 4, that is 8. Then we have to square now 8. So we have 8 squared plus, that is 6 plus 6, which is 12. Then we have to square now the 12. So let's get a calculator. We have 8 squared. We have 8 squared, that is 64. This is 64 plus, then we have 12 squared. I think that's 144. 12 squared, sorry for that. So we have 12, then you square it, that is 144, yes. Now we have to add the 2 and then we have to find the square root of both. So we have here 64 plus 144 That's going to give us 208. Then we must find now the square root of 208. So the square root of 208, the square root of 208. So that's giving us something like 4,42, 14,42. So this is the answer. 14,42 is the distance between F and H. So this distance is 14,42. That's the distance. So that was number one. Then let's look at number two. Number two, now they were asking us calculate the midpoint, calculate M, the midpoint of EH. So we said this is M. It is the midpoint between point H and E, or E and H. So let's find the coordinates of M with the midpoint. So we also have the formula that we are going to use to find the midpoint. This is the formula for the midpoint. Normally they said the midpoint is equals to x1 plus x2 divided by 2 and y1 plus y2 divided by 2. But here we are looking for the midpoint of H and E. So we have to take now x1 will be the x coordinate of H, then x2 will be the x coordinate of E. Then y1 will be the y coordinate of H, and then y2 will be the y coordinate of E. So we're going to substitute here the x coordinate of H, which is -4. Then I'm going to say plus, I'm looking now for the x coordinate of E, which is 14. Then I'm going to add 14 there. Then I divide everything by 2. Then I'm going to go to the y coordinates. So the y coordinate of H, which is -6. Then I'm going to say plus the y coordinate of E, which is -10. So I'm going to add -10 here. Then I'm going to divide everything by 2. Then I'm going to have -4 plus 14. That's going to give me 10 over 2, comma. Then I'm going to go to the other side. I'm going to say -6 plus -10. That's going to give me -16 over 2. Now I have to divide 10 divided by 2. That is +5. Okay, let me erase that. Yeah, 10 divided by 2, that is +5. Then -16 divided by 2, that's going to give me -8. So this now is my x and the y coordinate of the midpoint M. So this point here is actually, the x value is 5, the y value is -8. Yeah, it makes sense because if you look at this point, this has to be, let me make it straight. So let's check. This point, yeah, this point has to be -8 because the E point after that, the y coordinate of E is -10. You can see that the y coordinate of M is -8 and the y coordinate of E is -10. So it does make sense. So this point, and if you look at the x coordinate, this point is a point of F, which is x coordinate is 4, and the point of M, x coordinate is 5. So it's a little bit next to the fx coordinate. So the midpoint now, we have calculated it to be 5 and -8. So that was number 2. Remember, this is the midpoint formula. x1 plus x2 divided by 2, and the y1 plus y2 divided by 2. So you can copy this down and then check it again if you are following. Now I'm going to number 3. I'm going to number 3. In number 3, they were saying, calculate now the coordinates of G. Remember, G is this point now with the two unknowns. We don't know the value of x, we don't know the value of y. So now they said, let us find the coordinates of G. So let's look at this one. So we will look again at the midpoint formula to find the coordinates of G. So remember we said the formula for the midpoint is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. But now I am looking at the line FG. If you look at the line FG, M is still the midpoint of the line F and G. Now, I know the midpoint is 5 and the negative 8. The x-coordinate is 5, the y-coordinate is negative 8. I know the x-coordinate of F is 4 and the y-coordinate is 6. But now I don't know the coordinate of x for G and the y-coordinate of G. So I'm going to use now the midpoint formula and say I am looking now for the coordinates of G, which is a line FG passing through the midpoint M. The coordinates of the midpoint are known. So under this midpoint M, which is the midpoint of FG, I'll write now the x-coordinate is 5 and the y-coordinate is negative 8. I know the midpoint, but now I'm looking now at the x-coordinate of F, which is 4. And I'm looking now, I'm going to say plus the x-coordinate of G, which is x. And I'll divide this by 2, comma. I'm going to look at the y-coordinate of F, which is 6. Then I'm going to say plus the y-coordinate of G, which is y. So that is unknown. Then I divide that by 2. Now let's look at this now. This is the x-coordinate of the midpoint, and it should all go together with the x-coordinates. This is the y-coordinate of the midpoint. It should go with the y-coordinates. So I'm going to say here 4 plus x over 2 is equals to a 5, and the y plus 6 or 6 plus y over 2 is equals to negative 8. Because I know the y coordinate is negative 8, so it goes with it. All of this now represents the y coordinate, and all of this represents the x coordinate. So remember, this 5 is over 1, so I have to cross multiply here. If you cross multiply here, this denominator of 2 will multiply that 5, and this denominator of 1 will multiply that 4, 4 plus x. So 4 plus x will be equals to 5 multiplied by 2. That will be a 10. And this 8, negative 8 is over 1. I cross multiply. This denominator of 2 will multiply that negative 8. This denominator of 1 will multiply that 6 plus y. So I'm going to have 6 plus y is equals to 2 times negative 8. That is negative 16. Then I'm going to take now the 4 to the other side. So x now is equals to 10 minus a 4, which means that x is equals to a 6. And I'm going to say this now take the 6 to the other side. So I'm left with y is equals to negative 16 minus a 6. So y is equals to negative 16 minus 6. That is going to give you negative 22. So that means that now the g coordinate, the x value is 6, and the y coordinate is negative 22. So these are the coordinates of G. So if you know the midpoint of a line, you can use that equation of a midpoint to find the unknown coordinates of the point in that line. So this is how now we calculated the coordinates of G through the midpoint formula. Yeah, so pause your video and then look at it and try to follow and check if you understand what we did here. So now we'll move on to question number 4. So question number 4, we're saying now let us find the gradient of FH and the gradient of EF. So we're going to look now at two lines, which is HF, which is this positive slope here, And then we're going to look now at the gradient of EF, which is the negative slope EF. So this is the this is the gradient equation. So we have to use now the gradient formula. So for the gradient now, we have the formula, the gradient of the line HF. Remember, your M now for the gradient cannot look the same as the M for the midpoint. For the midpoint, we use the capital letter M for maybe a point X or the point O, for example. Then we can say x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. This is the midpoint formula. But the gradient formula, the M now is a small letter. The M for the midpoint is a capital letter. So you need to be careful now. These two M's cannot look the same. So we say it now. The M for the small letter is for the gradient of the line HF is equals to y2 minus y1 over x2 minus x1. So this y2 now will represent the point H. Okay, let's start with the, it doesn't matter the order. So you can start with the H, you'll start with the F. If you start with the H, this X will be the X1. Now this X for the F will be the X2. Now if you look at the H again, that Y will be the Y1, then the Y for the F will be Y2. You can start either by F or by Y, it doesn't matter, the answer will still be the same. So let's look now at Y2. We said Y2 is the F coordinate, so it's the 6 minus Y1 will be that of H, it will be a negative 6. Then we're going to divide by x2. x2 is the x of F coordinate, which is 4, minus x1 will be the x coordinate of H, which is negative 4. Then the answer will be, look at the numerator, negative times a negative, that's going to be a positive. Also the denominator, negative times a negative, that's going to be a positive. 6 plus 6, that's going to give you a 12. 4 plus 4, that's going to give you an 8. So if you want, you can put this in a decimal form or in a simple fraction. How many times 4 goes into 12? It goes 3 times. How many times 4 goes into 8? It goes 2 times. So the gradient here is 3 over 2. So the gradient of a line HF is 3 over 2. So now we're going to look at another gradient, which is the gradient of the line FE or EF. So the gradient of the line EF, so it's going to be y2 minus y1 over x2 minus x1. So let's take now this one as x1, this one as y1. So y2 now is a 6 for the F. So we're starting now with the F. We said the FY2 is a 6 minus the Y1, which is for the E, that will be a negative 10. You divide now by x2, which is the 4 for the F, minus now x1, which is a 14 for the E. Then you say now 6 plus 10, because a negative times a negative is a positive, over 4 minus 14. So 6 plus 10, that's going to give you, okay, let me erase that one. 6 plus 10, that's going to give you a 16. 4 minus 14, that's going to give you a 10. So which number goes here? Okay, 2 can goes into 16, I think 8 times. 2 can goes into 10, I think 5 times. So let's look at it again. Yeah, I think there's this number is a bigger number. 4 minus 14 is supposed to be negative 10. Yeah, because 14 is a bigger number, so we take the sign of the bigger number. So that means this is supposed now to be negative 8 over 5. Yeah, that's a negative 8 over 5. Now, look at these two gradients. We said now, if the gradient is towards the, what do you call it, the less values or less angles of 90 degrees, that gradient is negative, it's positive. But if the slope is looking at the angles that are greater than 90, then that gradient, we said it is negative. In other words, if your gradient is looking this way, this gradient is positive, but if your gradient is looking this way, that gradient is negative. So if you lift like your right arm and then you put your left arm down, that's positive. If you lift your left arm and you put your right arm down, that is going to be a negative gradient. So you can see here that the line FE or EF is a negative gradient. So that's why the value is negative. But if we look at the line FH, the gradient here is positive. That's why we got the positive gradient there. So these are the two gradients for the line EF and the line HF. Yeah, so now let's look at the last and second last answer question, which is question number 5. So you can pause the video, try to follow the two calculations and check if you are following. Okay, so the second last question says now let's calculate the equations of HF and the equation of EF. So we are going to need now this calculation or the method to calculate the equation, because in the next topic, which is the topic on the functions, so we're going to do a lot of equations, calculation of equations for the straight line graph in the function topic. So let's start doing the calculation of the equations in the analytical geometry so that we build now for the next topic, which is the topic on the functions. So I'll show you now how to find the equation of a line HF and the equation of the line EF. Okay, so here we'll start now with the equation of the line HF, this line with the positive gradient. Remember, this now was the calculated this one was the calculated gradient for HF or FH. So it was 3 over 2. In other words, this line, which is FH, has a gradient of 3 over 2. It's a positive gradient. It's the one that we calculated previously. So we're going to use a formula here for the equation of a line. The formula says y minus y1 is equals to m bracket x minus x1. So this is the equation that we use to calculate the gradient of a line. So remember, this line has 2 points, point F and point H. So let me interpret this formula. This y1 can be the y coordinate. If you take F, for example, point F is 6, the y coordinate is 6, and this x represents the coordinate of F, which is 4. So F has these coordinates 4 and 6, and then H has these coordinates negative 4 and negative 6. Now these 2 points, which is y1 and x1, if we take F, for example, this will be the x1, this will be the y1. So this y1 is now the y coordinate of F, which is 6. This x1 will be the x coordinate of F, which is a 4. So you can take F if you want. Then you can put there the y value of F and the x value of F. Or if you decide now to take, for example, the H value, the answer will be the same. You can say y minus y1 is equals to m x minus x1. Now, where you see now this y, you'll put the 6. Where you see this x1, you'll put the 4. The answer will be the same. So let's do that now. Let's start with the E, for example. Remember, this is the line FH. So let's say here we have y minus, where we see y1, we'll put a 6 equals to m. Where we see the x, when we see this x1, we'll put the 4 minus a 4. Then I'm going to go to the other side, do the same thing. I'm going to take now this y1 value, which is a negative 6, minus negative 6 equals to m. Where I see now the x1, I'm going to put that negative 4. Then I have to do my calculations. Okay, let's go back now to this one. So we said here y minus a 6. Remember, we do have the gradient of this line FH. We said this is the gradient of that line is 3 over 2. That's the gradient of the line HF. So you must have this gradient. Before you can find the equation of this line, you must first find the gradient of the line HF. So the gradient is 3 over 2 is what we have calculated previously. 3 over 2, we're substituting it now for this m. This m stands for the gradient of this line FH. Then we set bracket x minus 4. So we have to multiply now by this gradient to everything that is inside the bracket. So I'm going to leave this y minus 6. I'm going to say 3 over 2 times x is 3 over 2x. 3 over 2 times a negative 4. So that's going to be 3 times a negative 4. That's going to be a negative 12 over 2. So 3 over 2 times negative 4. That's going to be negative 12 over 2. So I'm going to say y minus 6 is equals to, I'm going to leave this 3 over 2x. What is negative 12 divided by 2? That's going to be negative 6. Now I have to take now the negative 6 to the other side. So I'm going to say y is equals to 3 over 2x. If you take this negative 6 to the other side, I'm going to have negative 6 plus a 6. So that 6 is negative. When you take it to the right, it's going to be positive. So the final answer now is y is equals to 3 over 2x plus a 0, because negative 6 plus 6, that's going to give me a 0. So that means this is a 0. So the final answer now for the equation of this line is 3 over 2x. Now, the line FH is passing at the origin. That's why it has no C coordinate. It doesn't have any Y coordinate. Remember, I'll show you when we do the functions. If a line is cutting through the original, this line is a line of y is equals to x. There is no C coordinate. But if a line, for example, you have a Cartesian plane and you have a line passing through now the x coordinate and the y, the x axis and the y axis, then this equation will be equals to y is equals to x plus c. C represents now the y coordinate, But in this case, we don't have the y coordinate. It's just passing through the origin. So it's like y is equals to x plus 0. That's why here we don't have any y coordinate is 0. But you'll see now when we calculate the equation of the line FE, there will be a y coordinate. I'm going to show you now on the other side. Remember, we use the same formula, y minus y1 is equal to mx minus x1. I said now you can take the point H. Now the x coordinate of H is negative 4. The y coordinate of H is negative 6. So I'm going to say y minus y1. So we took that y, which is negative 6. We substitute it here. So this is negative times a negative. That's giving me a positive of 6 equals. What is the gradient of that line? We have already mentioned that the gradient is 3 over 2. So I'm going to put the gradient here, 3 over 2. So if you now take the the x coordinate, which is negative 4. This is the x coordinate, which is negative 4. So okay, yeah, let me put it like that, negative 4. Then let's multiply it by this gradient. 3 over 2 times x, that is 3 over 2x. 3 over 2 times the negative 4, that's going to be negative 12 over 2. Y is equals to 3 over 2x. Now, what is negative 12 divided by 2? That's negative 6. We take the 6 that is on the left to the right. It's going to be positive 6. Oh yeah, this is what my mind was thinking about. Here we were proving that this point is going to be the same. Yeah, that's what I was trying to say. Otherwise, I forgot that this was the same gradient. So, because of this is the same point, I was proving to you that even if you take, for these 2 points, even if you take a point F or point H, the answer was going to be the same. Okay, yeah, that's what I was trying to prove. But the equation now FE is going to be the same. It's going to be different from this equation. But I was proving to you that when you use this equation, you can take point F or point H, the answer was going to be the same. Yeah, that's what I was trying to prove here. Y is equal to 2 over 2x, y is equal to 2 over 2x. You don't have to do both. You have to do one point. You can take point F, then you substitute it for y1 and x1. Or you can take point H, substitute it for y1 and x1. The answer is going to be the same, because of the gradient of these 2 points is the same. You don't have to do both. You just have to do one point. You can take H or can take F. Yeah, that's what I was trying to say. But the formula must remain y minus y1 is equal to mx minus x1. Now, let's find the equation of the next line, which is the line EF. We can also take point F or take point E. You can pause your video, try to follow what is going on here, and check if you can understand. Okay, so we are trying now to find the equation of the line EH, the line that has a negative gradient. If you remember, we calculated this gradient to be negative 8 over 5. So we use the same formula, y minus y1 is equals to m bracket x minus x1. So for y1 and x1, you can take the coordinates of E or you can take the coordinates of F. The answer will be the same. So these are the coordinates of F, which is 4 and 6. These are the coordinates of E, which is 14 and the negative 10. So you can take any of these, you'll get the same answer. So let me take the coordinates of F. So I'm going to say y minus y1 will be that 6 equals to, what's the gradient of this line? Gradient is negative 8 over 5. Then I'm going to say bracket multiplied by x minus, what is x1? It's going to be 4. Because if I'm looking now at the coordinates of F, which is 4 and 6. So I have y minus 6 is equals to negative 8 times x. That's negative 8 over 5x. Negative 8 over 5 times negative 4. That's going to be 8 times 4, which is positive 24 over 5. So it's going to be positive 24 over 5. Then we have to now take the 6 to the other side. So I have y is equals to negative 8 over 5x. Take that 6 to the other side. So when you take that 6 to the other side, it's going to be positive 6. Remember, this 6 is over 1. So I have to add now these two like terms. So we have y is equals to negative 8 over 5x. Y is equal to negative 8 over 5x. 24 over 5 plus 6. Okay, let's quickly do that one here. So we have 24 over 5 plus 6. That 6 is over 1, so it's the same. So if you punch this in a calculator, you get 54 over 5. Positive 54 over 5. Yeah, so this is your equation. I think you can leave it like this, or if you want you can simplify it further by multiplying everything by 5, but you don't have to. Just leave it like this. So it's going to be y is equal to negative 8 over 5x plus 54 over 5. Now you can see now this is the y coordinate. Let's simplify this y coordinate so that you can see what is 54 over 5. So I'm going to leave this one like this. So just want to check what is 54 over 5. Oh, it is 10.8. So that means this coordinate now is 10,8. That means now this line is passing through this point. So, okay, I'm making now, I just want to get a straight line. Okay, let me use my lines. I think I do have the lines here. So let me quickly get the line so I can draw a straight line for you. Yeah, here is a straight line for this line EF. Can you see that this line now is cutting this y-axis at 10,8? Yeah, so it's cutting it at 10,8. That is a y coordinate. And it's cutting these x values. What is a point here at x? So if you want to find this point at x, then you have to make now the y 0. So let's quickly find that one over 5. Okay, let me do it on the side. We are not required to do this, but just for curiosity's sake, we want to find now what is the value at x. At what value does this graph cut the x-axis? So the equation now is y is equal to negative 8 over 5x plus 10.8. Now we know that if you make x 0, then we can find now this y coordinate. So if you make x 0, this is going to become 0 plus 10,8. That means the y coordinate is 10,8. That's what I was saying here, is cutting the y-axis at 10,8. But at what value does it cut the x-axis? That's what we want to find. So you have to make now a y 0. If you want y, you have to make x 0. But if you want x, you must make y 0. So I'm going to say now I have y is equals to negative 8 over 5x plus 10,8. This is my equation. Because of now I'm looking for x, so I'm going to make now y 0. If you make y 0, then here is 0 is equals to negative 8 over 5x plus 10,8. So take this 10,8 to the other side. It's going to be negative 10,8 is equals to negative 8 over 5x. So now we have to divide by negative 8 over 5 on the left, divide by negative 8 over 5 on the right to find the x. So this and this will cancel, then you are left with x. So let's find now what is negative 10 over 10.8 divided by 8 over 5, which is negative. Negative and negative is going to become positive. So let's just say 10,8, divide that now by 8 over 5. Divide by 8 over 5. So let's check. Divide by 8 over 5. So the x coordinate is going to be equals to 6,75. 6,75. Yeah, so that means that this x coordinate is 6,75. So this graph now is cutting the x-axis at 6,75 and cutting the y-axis at 10,8. How did we find these two values? Because we do have the equation of the line, which is negative 8 over 5x plus 10.8. You can find the y coordinate, you can find the x coordinate. Now for the first equation, remember this one, which was y is equals to 3 over 2x. If you want the y coordinate, the y coordinate is 0 because we're going to make x 0. If you want the x coordinate, the x coordinate is also 0 because you have to make y 0. Now, that's why it cuts at the origin because the y is 0 and the x is 0. Yeah, so this was the second last question. So that was question 5. We were required now to find the equations of h and f. Now, the last one is asking now, is FG perpendicular to EH? Is FG, the line FG, is it perpendicular to the line EH? So we have to now prove if FG is perpendicular to EH. So to prove this is easy. We're going to use the equation of the gradient for perpendicular lines. Okay, so to prove if the line FG, we are required to prove if the line FG is perpendicular to the line EH. So we are required to prove this if FG is perpendicular to EH. Now, I said to you that we need first to find the equation of the gradient of the perpendicular lines. So the equation is saying if the gradient of FG multiplied by the gradient of EH, if you multiply both gradients and your answer is -1, that means therefore that FG will be proven to be perpendicular to EH. If when you multiply the gradient of FG by the gradient of EH and the answer is -1, then you can conclude that FG is perpendicular to EH. But if you multiply the gradient of FG by the gradient of EH and you don't get a -1, that means that EFG and EH would be not perpendicular. So we have to prove now by multiplying both. So what is the gradient of the line FG? What is the gradient of the line FG? That's what we have to find first. Then we find the gradient of the line EH. I think we know the coordinates of G. We said it's 6 and -20. Is it -22? Let me check. Yeah, it's 6 and -22. So let's quickly find now both gradients, and then we're gonna substitute there. So I'm gonna first find the gradient of the line FG. So that is y2 minus y1 over x2 minus x1. So I'm looking now at FG. This is this is x. This is x1. I'll take this as x2. This is y1. I'll take this as y2. So y2 now is -22 minus y1 is 6 over x2 is 6, then minus x1 is 4. So -22 minus 6, that's going to give us -28 over 6 minus a 4, that's going to give us a 2. Then divide -28 by 2, that's going to be 14. Let's check. 28 divided by 2. Yeah, that's a 14, and the 14 is negative because we divide a negative by a positive. So the gradient of FG is 14, -14. So I'm going to put it here. The gradient of the line FG, I got it to be negative 14. Now I need to multiply it by the gradient of the line EH. So let me quickly find the gradient of the line EH. So I'm going to say y2 minus y1 over x2 minus x1. That's a great equation of a gradient. So I'm going to make this now my x1, going to make this my x2, take this as y1, take that as y2. It doesn't matter the order. If you set these ones as x1, y1, x2, y2, the answer will be the same. So what is y2? y2 is negative 6 minus what is y1? y1 is negative 10 over, now we go to x2. What is x2? x2 is negative 4 minus what is x1? x1 is 14. So we expect a negative gradient because of it's also greater than 90. So negative 6 plus 10, because of this is negative 6. Negative and negative, that's a positive. So it's positive 10. Here we have negative 4 minus 14. So what is negative 6 plus 10? Negative 6 plus 10 is going to give you a positive 4. A positive 4 over negative 14 minus negative 4 minus 14. That is negative 18. So this is negative 4 over 18. How many times 2 goes into a 4? It goes 2 times. How many times 2 goes into 18? It goes, is it 6 or 7 or 8? Not sure. So let's say 18 divided by 2. Yeah, it's a 9. Forgot that one. Yeah, so the gradient of the line EH is negative 2 over 9. So I'm going to put this negative 2 over 9 here. So remember, this 14 is over 1. Now, if I multiplied both and I don't get negative 1, that means these two lines are not perpendicular. Let's multiply them. So I'm going to say, okay, bracket, I'm going to have a fraction of negative 14 over 1 multiplied by another fraction, which is negative 2 over 9. Okay, I don't think I'll get a negative 1 here. No, don't get a negative 1, we get a positive 3.11. Yeah, for proof's sake, you can see that when you multiply both gradient, we don't get negative 1. So we can say here, therefore, line FG is not perpendicular to the line EH. Not perpendicular. Okay, I'm going to write the not now. Not perpendicular to EH. Not perpendicular. I think we have to say not like that. No, I'm joking. So you have to write it now in words. FG is not perpendicular. You don't have to write the word, you can just put it is not perpendicular to EH. Yeah, so we have proven that the line FG is not perpendicular to EH. Yeah, so if they were equal to negative 1, if you multiply them and they give you negative 1, then you can say FG is perpendicular to EH. But if it is not equal to a 1, negative 1, then that means it's not perpendicular lines. Yeah, I think we came now to the end of our exercise. So we have answered all the questions from question 1 up to question 6. So this is the whole chapter on the analytical geometry. Now I'm going to the topic of the functions. So I'll find a question where we will answer. There are 4 types of graphs that we have to do: the straight line graph, the quadratic graph, the exponential graph, and the hyperbolic graph. So I think I'm going to make a video for each. I'm going to make 4 videos, a video for the straight line graph, a video for the quadratic, a video for the hyperbolic graph, a video for the exponential graph. Yeah, this one was very long. Sorry for that. I wanted to cover everything that will be required to calculate for the analytical geometry. See you in the next video.